MAT 3531 Differential Equations 2. This course contains 4 lessons. First order ordinary differential equations. The second one higher order ordinary differential equations. Third lesson first order partial differential equations, and the last one is the second order partial differential equations. So we will start the first lesson, that is lesson 1, first order differential equations. So a differential equation is an ordinary differential equation if the unknown function depends only on one independent variable. So differential equation is that ordinary differential equation if that unknown function only depends on the one independent variable. If unknown function depend on two or more, that is two or more independent variables, then that differential equation, that's partial differential equation. That is a difference between the ordinary differential equations and the partial differential equations. So then order of the differential equation. The order of a differential equation is the order of the highest derivative. That is highest derivative appearing in the equation. Order means the highest derivative. So we will see some example for it. These are the examples. So here dy by dx minus 5x minus 3 equals 0. Then highest derivative is here dy by ds, that is 1. Right, here 1 is there, we not written here. Then the order is 1, and degree, that is also 1, no, degree is also 1 here. And second example, d squared y over dx square to the power 3 plus 3y dy by dx to the power 7 plus y cube dy over dx to the power 2 equals 5x. Then here, so the maximum derivative here, that maximum derivative is 2. It means maximum derivative, we call that order, right? So then maximum power, that is 7. This called degree. So here order is 2, degree is 7. Right, here order is this one, no? Then order is 2, then degree is this one, that is 4. Right, then note. So then this is a notation. So normally we are denoting y dash means dy by dx, y double dash means d squared by x, d squared y over dx square, then here d cube y over dx square. That is the notation. So then we look about the standard form of a differential equation. A standard form of a first order differential equation, a standard form of for a first order differential equation is unknown function yx. So we can write y dash equals fxy. That is the standard form, and differential form of that equation is m x comma y dx plus n x comma y dx. That is the notation. So this is the standard form. This is the standard form, and this is the differential form. Right, these are the standard forms and the differential forms of the differential equations. Then we have to know about the linear equations. Then this is the equation from the standard form y dash equal fxy. So if fxy can be written as this form fx comma y equals minus pxy plus qx, then it is linear equation. So we can take this minus pxy for that side, then fxy we can write as y dash. So then the form is converted this way: y dash plus p of x y equals q of x. If a equation is given that form, right, then it is a linear equation. So we can see equation in this form, it means that is a linear equation. So then integrating factor, so you learned these things in earlier also. Then integrating factor we are denoting I of x equals e to the power integration p of x dx. This is the integration factor. And integrating factor depends on x and y. X and is independent of y. It means integrating factor depends only on x. Only on x. It is independent from y. Right? When the both sides are multiplied by integrating factor, then resulting equation is come like this way. That is a exact equation. Right? So we will do examples. Right? Find an integrating factor and solve for y dash minus 3y equals 6. So we can write this equation y dash minus 3y. So you can take that, you can write this equals 6, and I am naming this is as first equation. Then so we know that there is a form, linear equation. This one, y dash plus p of xy plus p of xy equals qx. You can see that form in here, no? Here y dash is this one here, px you can take as this one, and q of x also here. So then we can write this is this is a linear equation. This is a linear equation of the form. We knew that the form of the linear equation, that is y dash plus p of x equals p of x y equals q of x. Here this form, y dash plus p of x y plus equals qx. So where y dash equals, y dash means this one, y dash is given, so no need to write y dash. Where p of x we can write, where p of x equals, here p of x means this part, that is minus 3 and q of x equals 6. So then this is a linear equation now. So then we can solve this. So here find an integrating factor and solve for this one. So then we are going to solve this. So we found that p of x equals minus 3 I'm going to integrate this. So integration p of x dx equals minus 3 integration of minus 3 dx. So we can take so v of x dx equals minus 3 times dx. So integration of dx means x, so we can write answer as minus 3x. right? This is the answer. So then we can write the integrating factor. Integrating factor Ix. How we can write the Ix? Ix equals e to the power integration of px dx. So we can write I of x equals e to the power px times dx. So we found integration of px times dx equals minus 3x. So we can substitute here. So then I of x equals e, instead of this part we found the value, that is minus 3x. Then this is the integrating factor. Then this is the equation 1. So we multiplied this equation 1 from the integrating factor, that is y dash minus 3y equals 6. So multiplying both sides by integrating factor, so it means we are going to multiply it 1 by I of x. Then we can take that I of x e of this one, no? So here you might then we can write integrating factor is y minus 3x times y dash minus 3x times y equals 6 times e minus 3x. So we multiplied whole equation by integration factor, that's all, right? This equation multiplied by integrating factor, then it comes as this way. Then so here, no, okay, look at this one then. This part, so we can write advance. Before that I will take this one, y times e minus 3x. So I am going to differentiate this. I am taking f of x equals this one. So I am writing f dash x equals I can write e of 3x. I am differentiating this times dy by dx plus then y times differentiation of e to the power minus 3x is 3, then this need to multiply it by minus 3. So we can take e minus 3x, instead of dy by dx I am writing y dash here minus 3 e minus 3x times y. So look at this one. And this part, what can you say? Both are same. So instead of this part, so this is the, so we can write this is equals d over dx times this one, y times e value minus 3x, e to the power minus 3x. So equals the other side as this way, as it is, minus 3x. Now I can take I can send dx for that side and take the integration of both sides here. Then d times y times e to the power minus 3x equals integration e times minus 3x times dx. So here this d and this cancel, then here coming y times e to the power minus 3x equals 6. So we can integrate this e times minus 3x divide by minus 3, and we have to add a constant plus c. We can write where c is an arbitrary constant, where c is an arbitrary constant. So here we can now write y e to the power minus 3x equals, here we can cut, no, minus 3 times 1 minus, here comes minus 2. So answer is minus 2 e minus 3x plus c. So we can divide both side by this one. So y 3x. So if we divided this by here remaining y only, and equals here c, and I'm dividing and show you, then you can really see. Dividing both sides by e minus 3x, this one also e minus 3x, this one also e minus 3x. Then you can take the answer as here y c times e value 3x, that's come to up, then in this index is come as positive, this can be cancelled, minus 2. This is the answer. Okay, right? So you can solve this kind of problem like this way. And right, so another example, find integrating factor for y dash plus 4 over x times y equals x4. So I'm writing this again, y dash plus 4 over x times y equals x4. So you can see that this is also a linear equation. Y dash here 4 over x means p of x times y equals x4. x4 is the q4. So you can write this is a linear equation of the form what is the form of a linear equation? Y dash plus p of x times y equals q of x, where then we can write the values. P of x equals 4 of x, and qx equals x to the power 4, right? So then we can find the integrating factor. Before that, we are going to integrate p of x here. 4 over x times dx. So we can write this 4 times 1 over x dx. 1 over x dx means this is ln x. So this come 4 times ln x. Then this can write, so you can send this as a power to here, since that is ln, so you can write ln x to the power 4. So this is integration of p of x. So then we can write the integrating factor integrating factor that is I of x so I of x equals e to the power integration p of x dx. So we found this value, that is p of x dx means here dx, p of x dx means ln x4 x to the power 4. So e to the power ln means these two cancelled, e to the power ln, right? So remaining only x4. Then I of x equals x to the power 4 then, right? Then multiplying, same steps, multiplying both sides by integrating factor. So I name this equation as 1, then 1 multiplied by I of x, that x to the power 4, I of x is x to the power 4 times y dash, plus x to the power 4 times 4 of x y, plus x to the power 4 times x to the power 4. So here comes x to the power 4y dash, plus here you can cancel 1, then here create 4 times x to the power 3y equal x to the power 8. So then this is again as I mentioned in a previous example, so we can write directly d over dx times what, y times x to the power 4. So you can expand this and see whether you can get this. So if it is in this way, you can directly write this way, right? That is x to the power 8. Then I am sending dx for that side and taking the integration d times y x to the power 4 equals integration x to the power 8 times dx. So here remaining only y x to the power 4 equals here x to the power 9 divided by 9 plus c, where c is an arbitrary constant. This is the answer, right? So there you can solve this way. So then next type of equation is the Bernoulli equations. A Bernoulli equation is a Bernoulli differential equation is an equation of the form y dash plus p of x y equals, this part is same as the linear equation, equals q of x times y to the power n, q of x times y to the power n. Then here where n denotes a real number, this n is a real number. When n equals 1, it means here creating 1, and sorry, n equals 0, it means y to the power 0 means this part is no, right? It means qx. and n equals 1, n equals 1, there is only y. The Bernoulli equation is reduced to a linear equation. So you can reduce when n equals 1 and n equals 0, this Bernoulli equation reduced to the linear equation. If we reduce for that for the linear equations, we know that how to solve it, as we discussed as the previous equations, how to solve the linear equation. So if we converted Bernoulli equations into the linear equation, so we can solve it. So to do this, we transform a Bernoulli differential equation into the linear equation using the substitution. You have to use that substitution. What is it? Z equals y to the power 1 minus n. So you have to remember that. So you have to identify. You have to remember this form also. And if it is given, if a given equation in that form, you have to use this substitution. Z equals y to the power 1 minus x and convert into the linear equation. Then you have to solve it. Right? So we will discuss through an example. So this is the example. Solve dy by dx plus xy equals x to the power d squared y over dx square. Look at this one and compare with this one. Y dash is there, no? Dy by dx. Xy, y is there, p of x equals then x. X times dy squared over d squared y over dx में here y to the power n, that is also there. Then it means this is a Bernoulli equation. So we can write, so I'm taking this as first equation. So we can write this is a Bernoulli equation of the form so form is y dash plus p of x times y as previous way. Then here q of x also as same, and additional y to the power n, where p of x, value of p of x equals here, that is plus x, and q of x equals this one, that is x, and n, yn, it means y to the power 2, it means n equals 2. Okay, right. So then we knew that the substitution we have to, if it is a Bernoulli equation, we have to use this substitution, that is z equals y to the power n 1 minus n. So we can write by substituting substitution is y equals z equals y to the power 1 minus n. So then here n equals 2, no? Here n equals 2, so we can write z equals y to the power 1 minus 2, that is z equals y to the power minus 1, it means 1 over y. Since z is equals 1 over y, so we can write y equals 1 over z. So I have subject y, so then we can find dy by dx equals here if we take z minus 1, it means if we differentiate this, it is creating z minus 1, this 1 minus z square times dz over dx. So I differentiate y equals 1 over z, then dy by dx equals minus 1 over z square times dz over dx. So then we can write by 1 we can write, I'm going to substitute. So this dy by dx, instead of dy by dx we found value, that is 1 minus 1 over z square times dz over dx. I substituted that, plus x times y, instead of y I can write 1 over z here, 1 over z equals x dy by dx squared. So we have to integrate this one again. So d squared by over dx square, that's creating this come minus z square. This is wrong, so we have to correct this. Y to the power n here, so this equation is wrong. So here you have to write y to the power 2, right? X y to the power 2, that is the question. So then y to the power 2 means y we found that 1 over z, then 1 over z to the power 2. This question is wrong, you have to correct this as x y to the power 2, then it's okay. Then we can simplify. So I am multiplying by z square, then here remaining minus dz over dx, plus if I multiplied by z square, 1 z is remaining here, x z and z square is here, then it is cancelled, only x is here, and I'm multiplying by minus 1 again, dz over dx minus xz equals minus x. This is the second equation. So then look at this one, dz over dx, that is z dash plus p of x z minus q of x. So this is a linear equation, so we can write this is a linear equation, this is a linear equation of the form is, what's that, z dash plus p of x times z equals q of x, where p of x equals minus x, here minus x, and q of x also equals to the minus x. Now the simplification is same as the linear equation, so we have to find the integrating factor. So before that we need to find p of integration of p of f dx equals integration of minus x times dx. So then here that's come x minus x square over 2. So then you have to multiply it by integrating factor by first equation. Before that we have to find the integrating factor now. Then integrating factor is I of x equals e p of x dx, right? E to the power p of x, we found the value, that is, this is the value, minus x square over 2. This is the integrating factor. Then we have to multiplying both sides by integrating factor. So it means first equation multiplied by I of x. What is our first equation? Dy y dash, I'm writing the first equation there, then it is easy. Y dash plus xy, oh sorry, we need to multiply it second equation. No, that is the exact equation, linear equation. So here second equation we need to multiply it by I of x. Second equation is this one, z dash minus xz minus x minus xz equals minus x. This is the second equation. With this equation we need to multiply it by I of x. I of x is e to the power x squared over 2. So we multiply, then e to the power minus x square over 2 times z dash minus e times minus x square over 2 xz equals minus x times e to the power minus x square over 2. So you know that if it is in that form, we can write directly d over dx times, I explained this, e to the power minus x square 2 times z, right? This side as same way, e to the power minus x square over 2 times x. And so you can integrate both sides. So then integration d minus x square over 2 times z equals minus integration e minus x square over 2 times x times dx. This is the third equation. No, we can simplify further. That side we can simplify now. Then here creating here e to the power minus x square over 2 times z equals minus integration e to the power x squared over 2 times x dx. Third equation. So we can simplify furthermore. So then that is, so we can substitute value for instead of e to the power x squared over 2. So I let t equals e to the power x square over 2. Then we can differentiate both side dt by x. So here comes dt over dx. So integration of ex is the same value, x square over 2 times half is here, here minus 2x. Yeah, so then we can cut this 2 and 2. Then here we can write dt over dx equals minus here minus x times e x square over 2. That is dt over dx. Then I am sending minus sign here. Minus dt equals x times e minus x square over 2 times dx. So here we can create the this. Look at this one, and this one, both are same. So by 3 then we can write by 3 by third equation. Third equation is z times e to the power x square over 2 equals minus sign is there. Instead of this we can write minus dt. So z e minus x square over 2 minus minus plus dt. See here integration sign, so we have to write integration sign also there. Then here dt. So what happened then? X e minus x square over 2, if we integrate this, here comes t plus c, where c is an arbitrary constant, an arbitrary constant. So we sub z, we take z as what? Z is where? Z 1 over y. So instead of z we can write 1 over y times e minus x square over 2 equals t. We take this one, e minus x square over 2 plus c. If you want we can subject y. So to do this I am dividing both sides by e to the power x square over 2, then here remaining only 1 over y. Then if we do here 1 plus c, 1 over means we can write with the positive index x square over 2. Then y equals 1 over 1 plus c e x to the power 2 over 2. This is the answer. So this is the first part of the video. I'm going to talk about the other parts in the next video.